Let's look at our last lesson for this chapter of 5.2. We are talking about right triangle word problems, dealing with trigonometry. So we were asked to find x and y. So let's go ahead, and we know what theta is. Theta is the 30-degree angle. So this would be opposite, this would be adjacent, and this would be the hypotenuse. So we're going to use one of our trig ratios, well, two of them actually, in order to find the missing sides, x and y. So if I want to find x first, x is adjacent and hypotenuse because we have the hypotenuse. So that would be cosine. So cosine of 30 equals x over 15. So in order to solve this, we're going to have to multiply by 15 on both sides to simplify that out. Our theta, our angle, is in 30. So whenever we put this in the calculator, we're going to go to mode and make sure we're in degree mode. And then we are going to put in 15 times cosine of 30. And whenever you do that, you get that x equals 12.99. Okay, we'll just go to two decimal places. It doesn't specify here. So 12.99. So then we need to find our y, which is our opposite, so we can use sine. So sine of 30 equals y over 15. So same thing to solve, so times 15 times 15. So y is 15 times sine of 30. When you put it in your calculator, you get 7.5. So we were able to find both of them using our trig functions. All right, let's go to the next one. All right, theta, let's go ahead and label opposite, adjacent, and hypotenuse. Okay, so we have the adjacent. We need to know the opposite and the hypotenuse. So I'm going to do, let's do cosine would work. Cosine of 30 equals 105 over r. So we need to look at it more like this. And in order to solve for r, we could multiply by r and then divide by cosine 30. But an easier shortcut would be to switch these guys. So r equals 105 over cosine of 30 using basic algebra. So that's what we're going to put in the calculator. Make sure your calculator is still in degree mode. So 105 divided by cosine of 30. So r equals 121.24. Okay. Make sure you're using your calculator and following along. Make sure you're getting the same values as me. Let's go to the next one. I want to use the adjacent to find the opposite. So that means I can do tan because opposite over adjacent. So tan of 30 equals y over 105. Okay, the same thing that we did a minute ago. We can put this over 1 and then switch these guys around. So y is found by doing 105 times tan. Well, that should be times tan of 30. So 105 tan 30. 60.62. So y equals 60.62. Okay. And then just to double check it makes sense, r is a hypotenuse, it's 121. It is the longest side, so that works out. And then if you look at the last one, the hypotenuse is 15. It is the longest side out of all those. All right, let's get at the applications of the word problems. A surveyor is standing 50 feet from the base of a large tree. Surveyor measures the angle of elevation to the top of the tree as 71.5. How tall is the tree? So a surveyor, here's my surveyor. He is standing 50 feet from the base of the tree. So here's our tree. He's standing 50 feet. to the top of the tree. So the angle to the top of the tree is 71.5. It says how tall is the tree? So we want to know that value. So we look at what we know. We know this is adjacent and this is opposite. So opposite over adjacent is tan. So tan of 71.5 equals x over 50. Multiply both sides by 50. We get 50 times tan 71.5 equals x, or x equals. Put that in the calculator. So 50 tan 71.5, 149.43. How tall is the tree? I'm going to write it in words. The tree is 149.43 feet. Okay, let's look at the next one. You are 200 yards from a river. Rather than walking directly to the river. Okay, so here's our river. Here's me. We are 200 yards from the river. 200. Okay. Rather than walking along directly to the river, you're going to walk 400 yards in a straight path. Find the acute angle between this path and the river's edge. So this path and the river's edge, that'll be your theta right there. Okay, so we have a right angle here. So we have the hypotenuse and we have opposite. So that means we're going to use sine. So sine of theta equals 200 over 400. So let's just reduce it real quick. Sine of theta equals half. So in order to find what the angle is, what sine is as an angle, we're going to do the inverse of 1/2. I think we wrote it like this. So in our calculator, that's what we'll do. Second sine 1 over 2, which is 30. So find the acute angle between the angle's path. So it's 30 degrees. The angle is 30 degrees. Okay. Number 3, find the length C of the skateboard ramp shown in the given figure. Find the horizontal length A of the ramp. Horizontal length of the ramp. So here's our ramp, right? So that's what we want to find. So we have opposite and we have hypotenuse. So I want you to go ahead and do that one. So pause the video, solve this out. Okay, let's go to the next problem. In traveling across flat land, you notice a mountain directly in front of you. Its angle of elevation to the peak is 3.5 degrees. After you drive 13 miles closer to the mountain, the angle of elevation is 9 degrees. Approximate the height of the mountain. Okay, so you're traveling, so this is you, across flat land. Angle of elevation to the peak. Okay, so it's like this. So you drive 13 miles. This is 3.5. Then you drive 13 miles, get here, and you look again. And this time it's 9 degrees. Approximate the height of mountain H. Okay. So there's also this value right here, right? X. Okay, this is going to be a multi-step process here. Okay, we have the big triangle, so I'm going to write that here. Big triangle looks like this, 3.5, and then, oh, the whole thing would be 13 plus x, because you have to go the whole way if we're talking about the big triangle. Okay, and then this is h. So just using this, we have opposite and adjacent. So we have tan of 3.5 equals h over 13 plus x. Okay, so let's just kind of see what we can do to get h by itself. Okay, so 13 plus x. Okay, so 13 plus x times tan of 3.5 is going to give us h. All right, let's let that be for a minute. Let's go to the smaller triangle where he's closer. So it's more like this. Same height. Distance is x. The angle is 9 degrees now. Okay, so we have opposite and we have adjacent. So again, tan. So tan of 9 equals h over x. Multiply both sides by x. X times tan 9 equals h. Okay. All right, so see how these both set h? So that means I can actually set them equal. So I'm going to say 13 plus x times tan of 3.5 equals x times tan of 9. Okay, so I want to solve for x, and then I can plug that back in to find h. So we have a common variable here. We have x. So let's go ahead and, do a little distribution. So 13 tan 3.5 plus x tan 3.5 equals x tan 9. Okay, so then we need to subtract this x tan 3.5. Okay, so we have 13 tan 3.5 equals x tan 9 minus x tan 3.5. Okay, so just like I distributed 13 plus x, I'm going to factor out the x here. So I'm going to keep the left side the same. Okay, following? Okay, then our last step would be to get x by itself. So we're going to divide both sides by this tan 9 minus tan 3.5. Okay, so now we're simplified and we have what x equals. So now we are going to plug this in the calculator. So I'll show that one to you. Let me make sure it's in the correct mode. Okay. Go to your fraction. 13 tan 3.5 over tan 9 minus tan 3.5. Okay. 8.17835, so on. All right, so that is what x is. So we can write that x equals 8.17. So that's what goes here, 8.178. Let's just round to that. Okay, but remember we're asked for h. That's our unknown. So h can be found by doing either one of these. So x, so the 8.178 times tan of 9. Or you could do it with this one. So that's what I'm going to do. I'm going to use what they gave me. So that times, what is it? Times tan of 9. Okay. 1.295. So h equals 1.295 miles. So it says approximate the height of the mountain. The mountain is 1.295 miles. So that took a little bit of work, right? Perfectly fine. We got it done. Okay, let's look at the next one. Determine whether the statement is true or false. So we got to look at each one of these. All right, we have sine 60 and then cosecant 60 equals 1. So if we look back at our rules from previous, our trig ratios, trig identities. Remember this guy? This is 1 over sine 60. So we're going to keep this, but I changed out that. Well, when we multiply, these guys will simplify out and it equals 1. So 1 equals 1. So yes, it's true. Okay, let's look at the next one. Secant 30 over cosecant 60. All right. Something that we can remember is the complement. So I'm going to think about, see how they're complements to each other? 30 and 60 are complements. So say this is 30, this is 60. So secant is the opposite of cosine. So cosine is adjacent over hypotenuse. So we would do, let's call the adjacent to this, let's call this A and this C. So ABC. So for secant 30, let's just do that. Secant 30 is going to be the adjacent, the hypotenuse over adjacent. So that's going to be like C over A. So then cosecant is 1 over sine, and sine is opposite over hypotenuse. So I'm going to do hypotenuse over opposite. So sine of 60. So opposite, no, we do hypotenuse first. So that'd be C over opposite, which would be A. They are the same. These guys are the same if we look at it. So the deal is here, they are called co-functions. Remember that? Sine and cosine are co-functions. And then the other thing is 30 and 60 are complements. So if both of these things are true, then they will be equal to each other. And we can actually show that in the calculator. So let's just do, what was it, sine? No, it'd be cosine of 30, and then we'll hit the inverse. Okay, and then do sine of 60, do the inverse. Okay, I did it wrong. I needed to close my parentheses first. Let's actually close them. There we go. Okay, there we go. Now they're the same. So that proves it's also true. So that was 2 ways of proving it's true. Okay, the next one. Cotan squared 10 Cosecant squared 10 equals -1. All right, remember one of our identities. Let's go up to one of our identities. I'm going to try to find it here. Here we are. It was this one right here. 1 plus cotan squared theta equals cosecant squared theta. Okay, so let's, go back. Remember, these are on your formula chart too. 1 plus cotan squared theta equals cosecant squared theta. Okay, so these are the same angle. Theta can be any angle. So in this case, it's 10 degrees. Okay, so let's see how they rearranged this. I could do this. So I get 1, and then I could do -1 over here. That's what I really could do. All right, so cotan squared theta minus cosecant squared theta equals -1, which is the same thing here. All that's different is that the theta is 10. Okay, so this is true. All right, that is it for our notes.